This lecture covers the basic measures of frequency, including prevalence, incidence proportion, and incidence rate. When we talk about the frequency of health issues, we could mean three things: how many, what proportion, or how fast. How many means the raw count. For example, about 38 million US adults have type 2 diabetes. Proportion can mean prevalence or incidence. Prevalence is the proportion of existing cases. For example, 10% of the US population currently has type 2 diabetes. Prevalence is calculated by dividing the number of existing cases by the total number in the underlying population. For example, in this population of 50 people, 10 people have a disease. 10 divided by 50 is 0.2. We want to report the prevalence as a whole number, so we multiply by some multiple of 10. If we multiply by 100, we move the decimal place 2 places to the right and get 20%. So the prevalence of disease in this population is 20%. The next measure of frequency is incidence. Incidence means new, so these measures are about the frequency of new cases of disease that occur in a specific time period. There are two ways to measure incidence: as a proportion or as a rate. Let's start with incidence proportion, which is also called risk or cumulative incidence. It is the proportion of new cases that occur during a time period. For example, in 2021, there were approximately 4 new cases of type 2 diabetes for every 1,000 people in the US, which is the same as saying that the risk of type 2 diabetes was 4 in 1,000. Incidence proportion is calculated by dividing the number of new cases that occur within a time period by the total number of people at risk at the start of that time period. If someone is at risk, they could get the disease. At risk is not the same as high risk, which refers to an increased likelihood of getting the disease. At risk just means someone has the biological potential. For example, everyone who is alive is at risk of death. Someone is at risk for chickenpox if they currently don't have it and are not immune. Let's go through an example of calculating incidence proportion by answering the question, what was the risk of disease in this population last year? Let's start filling in our equation with the time period, which gives us new cases in 2023 divided by the total number at risk in the start of 2023. Usually not everyone in the population is at risk of the disease in question. Here, there are 10 people who were not at risk, so we can cross them out, and then put the total number at risk in the denominator, which is 40. Now for the numerator, the number of new cases that occurred in 2023, which was 5. We can do the calculation and get 0.125. We want to express this as a whole number of people. So let's multiply by 1,000 to move the decimal 3 places to the right. This gives us an incidence proportion, or risk, of disease in this population of 125 per 1,000 in 2023. The other measure of incidence is incidence rate, which is not a proportion, but a rate that tells us the speed at which new cases occur in a time period. Incidence rate is calculated by dividing new cases that occur in a time period by person time at risk. This is the number of people in the population at risk at the start of the time period, just like incidence proportion, but now we multiply it by the amount of time the people were at risk. Let's go through an example. Among 30,000 university students, 900 were diagnosed with COVID-19 in the 6-month period from 4/2020 to 10/2020. None of the students had immunity. What is the rate of COVID diagnosis? Round your answer to the nearest whole number and express per multiple of 10. Let's start with the formula for incidence rate. Let's plug in the numerator, which would be the 900 new COVID cases that occurred in the 6-month time period. Now let's plug in the number at risk at the start of the time period, which was 30,000. Finally, let's plug in the time period, which was 6 months. This gives us an incidence rate of 0.005. Now we need to round it to the nearest whole number and express per multiple of 10. 5 is the nearest whole number, which means we need to multiply by 1,000 to move our decimal over 3 places to the right. This gives us a final answer of 5 per 1,000. Now I'd like to talk about yearly or one-year incidence rates. If you'd like, you can click to go to the CDC visualization page to see where the example data came from. I selected myeloma as the cancer type on the CDC data visualization page to get this graph. Myeloma is a blood cancer. Each dot on this graph is the one-year incidence rate per 100,000. So, for example, the incidence rate in 2008 was 6.8 new cases of myeloma per 100,000 people in the US. How is this number calculated? Let's start with the formula for incidence rate. Then let's find out the numerator, which would be the number of new cases in 2008. We can do this on the data visualization page by hovering over the dot, which shows us that there were 20,308 new cases in 2008. After we plug this number into the formula, we need to find the person time at risk. When dealing with large populations like a county or even a state, the number at risk is unknown, so we use the mid-year population as the denominator. The mid-year population of the United States in 2008 was 299,106,000. This number comes from the Census Bureau. If you'd like, you can follow the link and download Table 1 to see where that number came from. We can plug that number into our formula. Now we just need the time period, which is 1 year. When the period of time in the denominator is 1, then incidence rate looks just like incidence proportion. When we do the math, we get 0.000068. Since the incidence rate on the map was per 100,000, let's multiply our answer by that, which gives us 6.8 per 100,000. And that's what our graph shows. One-year incidence rates are calculated for all major health issues in the US and are a good way to look at long-term trends over time. You'll notice a much lower incidence in 2020 as the result of the pandemic. People were not seeking medical care and so were not getting diagnosed when they otherwise would have. So we always need to interpret incidence numbers from 2020 with caution. Now let's talk about how to calculate an incidence rate from epidemiological study data, so a study that follows some number of people over time to see whether they get the disease of interest. In this study, 10 patients are followed for 12 months. The black lines show the amount of time each patient in the study was at risk of the disease. If someone gets the disease or drops out of the study, they are no longer at risk. They are no longer contributing at-risk time. The denominator of incidence rate is person time at risk. This is the number of people at risk at the start of the study multiplied by the time they were at risk. To get this number, we'll need to calculate the at-risk time each patient contributed. Patient 1 contributed 12 months, patient 2, 8 months. Once we've figured out the at-risk time for each patient, we can add them up to get the total person time at risk, which in this study is 87 months. Now we can plug in these numbers to the incidence rate formula. There were 3 new cases and 87 months of at-risk time, which we can call person months. This gives us 0.0345. This would be approximately 35 per 1,000 per 12-month time period. But it would be simpler to express it per year, so let's multiply our answer by 12 months since there are 12 months in a year. Now we get 0.414 new cases per year. Let's turn this into a whole number by multiplying by 10 and rounding to 4, giving us a final answer of 4 cases per 10 years. I hope that lecture was helpful in understanding measures of frequency. Next up is a video on 2x2 tables. Please let me know if you have any questions. Bye, everyone!